So let us see how this works. So my topic is satellite communication systems. So we will in this topic or in this seminar we can see how the communication systems around the world work with the help of the satellite. So here is history, and the history states the first satellite that was launched is the Sputnik satellite by the Russia, and all the chronologies have been given over here, so you can see that. Yes. And according to 1957, then the 1960 satellite, 1963 first geostationary satellite was SYNCOM, that was used to connect for the communication purposes. And then the Marisat comes in, then the INMRSat comes in. So this kind of different satellites has been launched to the like the orbit. So what are the applications that we can see over here to know how this satellite works? So what are the applications? The telecommunication is the main thing. The telecommunication is the main thing because it is used for communication, right? Satellite through communication through satellites. That is the topic. So the global telephone connections backbone for the global networks are already replaced by fiber optics. As we know, in Kerala, we see K phone or Kerala Vision. So we have many fiber optic internet providing services. So connections for communication in remote places or underdeveloped areas, global mobile communication. These satellites are launched into the orbit such so that even the remotest places of the country or the any kind of a remote place, there is no access. The access can be provided for the communication. Other applications are weather satellites. We know the weather, the radio, and the TV broadcast satellites. We have the radio in our smartphone. TV broadcasts are done through for the weather and anything, right? So these are done through with the help of the satellites that has been launched into the orbit. And at the same time, there are the military satellites. There are many military satellites, right? So they use for the covert operations and all. So satellites for navigation and localization. So we have many navigation apps such as GeoMaps, Gmaps, mainly the Gmaps, Google Maps. So we use this kind of map navigation systems through, and this kind of data feed comes from the satellite. So typical satellite system here is just a small, example how this satellite system works. So this you can, document has been shared in the group, so you can get an idea how this works. So yeah, so all this intra communication systems starting from the ISDN, PSTN, GSM. You know all the GSM gateway link, GW inter satellite link, ISL mobile user link, right? Now what are these? These are the basics that that we use for the mathematical calculations of this satellites to be launched into the orbit, or they have been already launched into the orbit. So using this kind of mathematical equations or calculations, one can make an idea of how the satellite works in the particular orbit in the mathematical way. So these are the satellite period and orbits, how the things work. Whereas the equator is the main thing that plays the role over here. And what are the basics? Elliptical or circular orbits. Where what are the basic requirement for a satellite to be communicated over the orbit? So first is the elliptical or circular orbit should be there. Complete rotation time depends on distance satellite Earth. Inclination, elevation. So elevation or inclination also depends on the communication systems, because as the inclination goes on, the communication systems differs, and as the elevation goes on, the some communication system differs. So what is the line of sight? Line of sight to the satellite necessary for the connection. Line of sight is something highly elevated needed because less absorption due to buildings. If we know that the Wi-Fi range, or that the Wi-Fi that we use, it has a certain range, right? So at the same time, if this satellite also has a certain range, but due to the buildings and all, this is the less absorption period. Yes. So the high elevation is needed as much as, so the line of sight is improved and it can be direct communication. Now the next is uplink, connection based station to the satellite. Means from the station itself, the station that is on the earth to the satellite, that is the uplink. Downlink is connection satellite from the satellite to base station. When the communication is going on from the base station to the satellite, that is known as uplink. And when the connection satellite communication is happening between connection satellite to the base station in the ground, that is known as downlink. Now the typically separated frequencies for uplink and downlink are given here. Transponder are used for sending and receiving the shifting of frequencies. So the communication happens in the form of frequencies, right? At a certain frequency, the communication happens. So for that, the transponder is used. Now the inclination you can see, yes, as much as inclination is given so that the line of sight is, properly given over here. So there is no this problem in this. And the link budgets or satellites, all these mathematical things are given over here that you can see for parameters like attenuation, parameters like attenuation and the received power determine the four parameters: sending, gaining. So these are the properties, or you can say these are the parameters of which the satellite is being used, how it is being used, how can be it regulated, right? So the first, this is the main important thing, that is the orbital satellite, right? So the first orbit is the geostationary orbit, that is the given range. And then comes the low earth orbit, that is LEO. Medium earth orbit or the intermediate circular orbit, that is the ME or ICO. And comes the highly elliptical orbit, that is HEO. So how this works, see, so you can see the geostationary orbit over here, the LEO is over here, the HEO is over here. So you can see that how the orbit works, how certain different orbit acts as in around the earth, right? So the altitude, inclination, apogee, altitude, all the things are given over here. Geostationary satellites orbit the distance to the Earth's surface, orbital and equatorial plane. Complete rotation exactly in one day. Satellite is synchronous to the Earth rotation. Means as the satellite moves, it is along with the movement of the Earth. Right? The how the Earth rotates, the satellite also will rotate at the same speed. Fixed antenna position, no adjusting necessary. Satellites typically have a large footprint, up to 34% of Earth's surface. Therefore, difficult to reuse frequencies because of the the rotation is being done along with the earth rotation. So larger footprint are covered, this satellites covers a larger footprint of the earth. So the reuse of the certain frequencies are not possible because it itself takes the entire frequency to communicate to, because it has a larger footprint, or it covers a maximum area, right? So the bad elevation in the areas with altitude above 60 to 60 degree due to fixed position above the equator. High transmit power needed because of this, constant rotation along with the earth. High transmission is needed for the communication. Like high latency due to long distance. Now latency is something that, delay, you can say latency is a delay. So it is due to long distance because at a certain distance it is there, and along with the rotation of the earth it is covering a large footprint, a large area. So that much power, or that much, this is needed. And as the power increases, the latency will also increase because due to the long distance. Now why not useful for the global coverage of small mobile phones and data transmission, typically used for radio and TV transmission. See, the geo is used for mainly radio and TV transmissions. Now comes the LEO system. LEO system orbit, as you know, 500 to 1500 kilometers. Visibility of standard 10 to 40 minutes. The global radio coverage possible. Latency comparable with terrestrial long distance connections. Smaller footprints. It compared to the Geo, LEO has smaller footprints. It covers less area, so better frequency. You say we can use. Handover necessary from one satellite to another. Many satellites necessary for global coverage. More complex system due to moving satellites. As it is the moving satellite, it is not. It does not only move along with Earth. It moves on its own, right? It is not in a stationary position like a geo satellite. It has a stationary position. LEO does not have a stationary position. It moves along. It can move along. So examples are Iridium and Global Star. Now the Global Star is in the 1999 satellite Global Star, now is overtaken by Elon Musk. Now the MEO systems, as we know, what are medium elliptical orbit systems, or you can say, as you can see, medium earth orbit, sorry, medium earth orbit systems, that is 5000 to 12000 kilometers. Now what are the comparison with the LEO systems? Slower moving satellites, it compares slower moving satellites, less satellites needed, much more satellites are not needed, simpler system design, so that it does not have a complex design. So the MEO, we can say it is easy to build, right? MEO systems are easy to build. For many connections, no need to have no handover needed. Higher latency, that you can see. Higher sending power needed. Special antennas for small footprints needed. Now This MEO system, that is medium earth orbit systems, covers a very remote areas, the very remote areas. So special antennas are needed for the smaller footprints, smaller footprints as in remote area or actual desirable area location. Now the comes the the example is the intermediate circular orbit INMASAT, that has been launched in 2000. Now comes the routing. Now all the satellites have to be routed from the base station to the communication satellite, right? Only the satellite is revolving around the orbit, is that is not the thing. It has to be communicated to the base station, that is on the earth. Now what is that? Reduced number of gateways needed. Only one uplink and one downlink per direction needed for the. As we know that uplink is something that is base station to satellite, and this is downlink is satellite to the base station. So direction needed for the connection of two mobile phones. Problems. What are the problems that we face in routing? Is more complex, focusing on antennas between satellite, high system complexity due to moving parts, higher fuel consumption, and thus shorter lifetime. This has a shorter lifetime. Okay, so this is Iridium and Teledesic planned with ISL. So these are the two satellites that are planned with the IS, that is inter satellite links. Now comes the localization of mobile stations, that is mechanism similar to the GSM. Gateways maintain register with the user data. Home location register static user data, and visitor location register, as you know, it is not a static user data. Last known location of the mobile station. As we know that HLR and VLR are used not only in the legal purposes but also in your phone. It is already there. It is already there. That is home location register and the visitor location register, right? So whenever you visit some place, it shows you a review type, right? So that is what VLR is doing. VLR is in the background, it is doing that you have visited so and so places, so and so location, so it is asking you a review, like Google Maps. Like if you go somewhere, like if you go to Payambalam beach, so it asks you a review, how was it. So the VLR is active there, right? Now, home location register, that it knows that it is your home area, means that static user data, means you are there in the location for more than a period of time. Now the SUMR, satellite user mapping register, satellite assigned to the mobile station position of all satellites. The SUMR are used to connect all the local devices to the satellite. Now this is the satellite user mapping register. Sorry. Now comes the registration of mobile stations. Localization of the mobile station via satellite position, as I said, SUMR are used. Requesting user data from HLR, that is the home location register, the static data, and updating VLR and SUMR. Right? So calling a mobile station localization, as you can see, you can read it over here. Now, certain handover are things that now what is this handover? Several additional situations for handover in satellite systems compared to the cellular terrestrial mobile phone networks caused by the movement of the satellites. Now, sometimes the satellite moves not according to us, right? So it moves on its own. So sometimes the terrestrial area occurs or any kind of block occurs. So there is a latency, there is a delay. So to contract that, this kind of handovers are needed in the satellite systems. So to cover, means if that time has elapsed, to cover that time, the time that has elapsed, this handover is needed. So intra-satellite handover, that is handover from one spot beam to the another, and the mobile station still in the footprint of the satellite, but in the another cell. Now inter-satellite and intra-satellite are different things. Intra is all over. Inter is in itself, right? Then comes the gateway handover, that is the gateway portal handover. The mobile station footprint of the satellite, but the gateway leaves the footprint. Now, if we go somewhere, this the if you go somewhere, so our area or our mobile system tracks the footprint, right? So we have so it shows that you have been to this as all these locations. So that is the gateway to what places. For example, if you are in Talipramba and you are going to Kannur, so it is Talipramba is a gateway and Kannur is a gateway. So from Talipramba to Kannur, those are the two gateways. But when you leave from Talipramba to Kannur, there is already a gateway saying that you were already present in Talipramba. So that is a gateway handover. And inter-system handover from the satellite to the terrestrial network might be, and mobile station can reach terrestrial network again, which might be cheaper as a lower latency. So what it is mobile station can reach a terrestrial network again, means the elapsed time network that can be cheaper, means the time that has been elapsed to cover that, the cost is cheaper, or you can say the
the network that we elapse that to regain that, it is cheaper, and that elapsed time has a lower latency. So that was my topic, and these are just calculation that you can already see that. Okay, so thank you.